Alrighty. So you gotta self-correct, you gotta undo all this stuff. First you gotta undo the stuff outside of the radical. So undo, this is 2 times, and this is plus, undo the plus first. So minus 6, and you've got 2 times the square root of x plus 4 equals a minus 4, and you pretty much stop right here, because if you undo the times 2, divide 2, you've got the square root of x plus 4 equals a minus 2. Now that's contradictory, no solution, because they want you to find the positive root, and they're saying that it is equal to a negative, so that's impossible. That's a trick question. If they ask you to find the positive root and they're telling you the answer is negative, then they're contradicting themselves. It's a trick question, no solution. Don't fall for it. This one on the right, 3 square root of 5 equals square root of a negative x. Okay, there's not much to undo with the x. We just got to undo the radical and undo the negative. So lift off the radical, square it, square it. And if you square this, you got to square the whole side. So it's 3 square roots of 5 times 3 square roots of 5. Or you take the 2 to both of them. Same thing. If you take the 2 to the 3, you get 3 squared. If you take the 2 to the square root of 5, that square undoes the square root, so you just have times 5. So that should be 9 times 5. So that's 45 equals a negative x, because this square kills that square root. So if a negative x equals 45, a positive x equals a negative 45. Just change that to a positive, change the signs, but you got to change them on both sides. Change that to a negative. Okay, this x, you got to undo the square, undo the divide, undo the minus 2, do that first. So you got x squared divide a minus 40 equals 3. Okay, undo the divide by a minus 40, so times by a minus 40, times this by a minus 40, divide 40 times 40, that undoes, so you got x squared equals 3 times minus 40 is minus 120. Okay, undo the square, so you're going to go square root, square root. Now the moment you do the square root, there's going to be 2 roots. Give me both, give me the plus and the minus. And this is a big deal, this is a big red flag. Square root of a negative, take that negative out. That is imaginary. So it's going to be plus or minus imaginary, square root 120. Okay, 120, bust it up. Let's pull some squares out of 120. 120 is 10 times 12. 10 is 2 times 5. That's prime, that's prime. 12 is 3 times 4. And 4 is 2 times 2. So in 120, there's not very much in 120. So plus there's not very many doubles, not very many squares. Here's what you got. You got a 2, a 2, a 2, a 3, a 5. And that's the only square you have. So if you take that square out, it's going to be plus or minus 2i. And then what's left on the inside is 5 times 3, 15 times 2, 30. That is your answer. Okay, last one. Undo the minus 16, so plus 16, plus 16. You got 2x squared equals a negative 16. Undo the times 2, divide 2, divide 2. X squared equals a minus 8. Undo the square, so square root, square root. The moment you take a square root, there's going to be 2 roots, the plus or minus, and take the negative out. So it's going to be plus or minus, that is imaginary, square root 8. And 8 is 2 times 2 times 2. That is your square. Take it out, your final answer is plus or minus 2 imaginaries times the square root of 2. Okay, 2 more. Okay, I got x squared and I got some x's. So I don't know which x to solve for. So I'm going to factor it. Bring this 4 over. Let's make it equal 0. So 5 minus 4, here's what you got. X squared minus 4x, that's a 0, that's a 0, equals 0. Okay, now, if you factor this, if you change this to a times problem, here's what you really got. You got x squared minus 4x plus 0 equals 0. So if you change this to a times problem, you're looking for something that timeses to give you x squared, that's x and x. You're looking for something that timeses to give you 0. So one of them's got to be 0. But it's got to add to give you a minus 4. So there we go. X times x gives you the x squared. X times minus 4 gives you minus 4x. 0, 0, 0 to that is 0. So that's it. Or x plus 0 times x minus 4, that's the same as x times x minus 4 equals 0. Okay, now you're looking for what you're going to plug in to make this be 0. Because if you're timesing and your answer is 0, that means you're timesing by 0. So there's going to be two solutions because it's quadratic. So your first solution, what would make this group a 0? If you put 4 in for x, 4 minus 4, that makes it 0. What would make this group a 0? If x was just 0 itself. So there's your two answers. Okay, this next one is not as easy, but it's similar. So you got x squared, you got 4x squared, you got minus 16x, you got 0 equals 0. Let's do the GCF. Let's change this to a times problem. Let's divide this. This is like your IXL AA2. What can you divide out of both of these? Let's divide them both by 4x. So if you change it to a times problem, it is going to be 4x times x minus 4. There we go. So now x is going to be, I think this exact same answers. X is going to be a 4, because if you put a 4 into that group, 4 minus 4 is 0, 0 times that's going to be 0, and 0. If you put into this group, you want to put a 0, because 4 times 0 is 0, 0 times that is 0. So same answers. Okay, this one on the bottom, write this in complex form. So that's the real part, that's the imaginary part. So let's do the top. If you got 1 plus I squared, that's 1 plus I times 1 plus I. So 1 times 1 is 1, 1 times I is I times 1 is I times I is a minus 1. So the 1 and the minus 1 are nothing. So on top you have got 2I. Okay, and on the bottom you got I times I times I. So you got I cubed, and that is a minus 1. So you got 2I over a minus I, and an I on top and an I on bottom will divide out. So you have 2 over a minus 1, which is B, a minus 2. Okay, I'm going to save this one. Let's do this guy. Out of the 77. If you got 77 I's, what do you have? You got to remember that every square is equal to a real, and it's equal to a negative 1. So then the question is, how many of these squares do you have in there? How many of these negative 1s do you have in there? So you have 76 times I. I to the 76 times I to the 1, and that is a total of 77 I's. Okay, now 76 is even. So how many squares are in 76? So if you pair them up, you're cutting them in half. So half of 76 is 38. So there are 38 squares in 76, and then there's this one left over. So you've got every square is a -1. So you got a -1 38 times I. And a -1 times a -1 times a negative. If you do it an even amount of times, the result's positive. If you do it an odd number of times, the result's negative. So this will result in a +1 times I. So your answer is I. Okay, this one, you've got 4i, and you've got I to the 7. So that is how many squares? That's 3 squares. 3 squares, that accounts for 6 of them. And then you got one left over. So every square is a -1. So if you have a -1 3 times, that is going to be, because you have it an odd number of times, it's going to be a -1. So here's what you got. On top you got 4i. On bottom you got a -1 times I. So it's kind of the same as we just did. I divided I is going to cancel. So your answer is 4 divided by a -1, or a -4. Okay, this one. This is probably more like a bonus question. This one's pretty tough. So two complex numbers. Complex is a real plus an imaginary. That's complex. So they have got to add and give you 4. So here's what you know. It's got to be 2 plus 2 could give you 4, or 3 plus 1. So if you have like 10 imaginaries here, then this would have to be a -10 imaginaries, because when you add up your imaginaries, you don't have any. You have 0 imaginaries. So they've got to all be, when you add them, they've got to be real. And the only way you can add them and have them be real is if your imaginaries add to 0. So whatever imaginary you choose, you have to choose its opposite, because a positive and a negative will create a 0. So they add to give you 4, and they times to give you 29. So let's look at what I just chose. If you do 2 plus 10i, and you times that to 2 minus 10i, so now if you times them, 2 times 2 will give you 4. 2 times a minus 10i is a minus 20i. And 10i times 2 is a plus 20i. And 10i times a minus 10i is a minus 100i squared. And I squared is a -1. So that's really a plus 100. And your i's are 0. And the 4 plus 100 is 104. So we just created 104. But we only need to create 29. So we kind of overshot it. So you know that you're going to get, if you do 2 times 2, that's going to give you 4. And I did 4 plus this. So if I want to end up at 29, I'm going to do 29 minus 4. 29 minus 4 is 25. I want to create a 25. And you can do that by 5 times 5. So here are your imaginaries. Your complex number is going to be 2 plus 5i times 2 minus 5i. So here we go. 2 times 2, that gives you the 4. 2 times minus 5i is a minus 10i. 5i times 2 is a plus 10i. 5i times a minus 5i is a minus 25i squared. And 10i and a negative 10i, that's 0. I squared is a -1. So that is a positive 25, and that's a 4, and that does times to give 29. And when you add it, 2 plus 5i 2 minus 5i. If you add them up, that's 4, that's 0. So it adds to give 4, it times to give 29. Okay, 5 more. 2 divided by 4 minus 8i. First, you could change that 2 to a 1, change that 4 to a 2, change that 8 to a 4. Because these can all be simplified. You got to do it to all of them though, all or none. Now you can never have an imaginary on the bottom. So you got to times this. Times it by 2 plus 4i. Times the top by 2 plus 4i. So it's kind of like what we just barely did. If we have 2 minus 4i, 2 plus 4i, that's going to create some zeros. 2 times 2 is 4. 2 times 4i is 8i. A minus 4i times 2 is a minus 8i. And a minus 4i times 4i is a minus 16. I times I is I squared. So that is 0. That I squared is going to change that to a positive, so it's going to be 4 plus 16. On the bottom, you should have 20. Okay, on the top, you're going to times just by 1, so it's 2 plus 4i. Clean them up. Do the 2, the 4, the 20, divide them all by 2. That's going to change to 1 plus 2i over 10. Final answer. Okay, take the negative out. So it is imaginary square root 15 times, take the negative out, imaginary square root 30. So times your imaginaries. Imaginary times imaginary is imaginary squared, which is a negative 1. So you've got a negative 1 times the square root of 15 times the square root of 30. That is negative 1 times the square root of 15 times 30. Bust them up. 15 is a 3 and a 5. 30 is a 15 and a 2. 15 is a 3 and a 5. So here we go. You really have two 15s. So that's your pair. So you can take out the 15s, or you can take out the 3s and the 5s and times, and that'll give you 15. So take out the 15s. So with the minus 1, you're going to have a minus 15, and on the inside, you have 2. And that is it. Okay, morph. Morph these guys right here. If you have an exponent and you're taking it to another level, you got to times them. So that is c to the 3 times 3/5. Times your tops times your bottoms. That is c to the 9/5. If you morph it, that is a radical. The c goes here. The 9 goes here. The 5 goes here. So it's a 5th root. It's going to undo powers of 5. And because you got 9 of them, that is the same as c to the 5 times c to the 4. So that 5th root is going to undo that power of 5. So c comes out, and you have 4 left over. But you got to put 5 there. It's a 5th root. Okay, this one is a good one. This one's probably like another bonus. So just start with the inside. Here's what you got. You've got that. So that is, if you morph, I mean that's a square root, and you got a power of 4. You got 2 squares in there. If you morph it, that is x to the 4 halves, which is x squared. So that first layer is x squared. So here we go. I got 1, 2, 3. So I got 1, 2, 3 x squared. Because we just took this guy this in layer and change that to x squared. Okay, now let's just focus on this guy. So you got the square root of x squared, and that is just x. If you morph it, it's x to the 2 over 2. So that is just x. So it's really not too bad. So now I got rid of that third layer, so now I just got 2 layers. 1, 2, and under there I just put x. Now it's not so bad. Alright, so anyway, we gotta change this guy. So that is a 1 and that is a 2. So if you morph that, that's going to be x to the 1/2. And you got one more layer left. So that is a 1/2, that is a 2. So it's going to be x to the 1/2 over 2, which is the same thing as, if you're going to take a fraction and divide it, times it by its reciprocal. So it's going to be 1/2 times the reciprocal, 1/2, which is x to the 1/4. Now, Garrett Kimball would like a shout out right here. He's looking for someone to ask him on a math study date. He's interested in someone taking him out maybe to the movies or to dinner, and then afterwards tutoring him in mathematics so he can get a good grade. So anybody interested in taking him up on this proposal, could be worth some extra credit, come and see me. Okay, last one. X to the 4/5 times x to the 5/3. If you're times in the letters, you add the exponent, so it's going to be x to the 4/5 add 5/3, and these are fifths and these are thirds. They're not like units. You cannot add them. You can only add them if they're like units. So fifths and thirds, you need to change them to 15ths. So if you change 4/5 to 15ths, that would be 12/15ths, and this would be 5/3 would be 25/15ths. So if you add 12/15ths and 25/15ths, that's going to be a total of 37/15ths. Ugh. Okay, now if you morph it, it's going to be x 37 and its square root of 15. So the 15th root is going to undo powers of 15. So, and if you got 37, you got 2 15s in there. So you got a 15, you got a 15, that's 30, and then you got 7 left over. So this 15th root is going to undo that 15, is going to undo that 15. So your final answer is x squared on the outside, the 15th root of x to the 7th. That is a good problem.